it. So my name is Todd Steiner. I'm the product marketing director for Trimble's geospatial optical solutions. So my team's been working very hard on a product we'd like to talk to you about called the SX10 Scanning Total Station. Many of you have seen it on the booth. If you haven't, please get a demonstration from it. So we're really excited to talk to you about it. The SX10 Scanning Total Station, truthfully, is the most innovative surveying product that Trimble's ever engineered. This truly combines high-speed 3D scanning, high-accuracy total station measurements, and enhanced imaging, all together in a seamless field and office workflow built for surveyors. So, we're really excited about what the team's been able to accomplish here. The innovation starts with our new EDM technology, Lightning 3DM EDM technology. So, Lightning 3DM is sort of three measurements, right? It's high-speed 3D scanning, it's true high-accuracy total station measurements to prisms, and reflectorless measurements, all combined into the same EDM telescope. On top of that, we have several calibrated cameras all working together to provide imaging both for site documentation, for precise pointing. This is, truly our most accurate total station, and to be able to point the total station, you need to be able to point accurately. So you do all that through imaging, and so we've got that system working. As innovative as the hardware is and how the technology is developed is the way that it's been implemented into the workflow. So it's built into familiar surveying workflows. So if you know how to go out and do a network adjustment or a traverse adjustment or shoot back sites, you know how to go operate this instrument and add scanning and imaging context to your field work. I talk about familiar operation and workflows. So this is really a product and a solution built by surveyors for surveyors. That's our customers. So if you're a surveyor, you go out and operate the same kind of workflows, both in the field and the office. I think one of the struggles that 3D scanning has had in the industry over the past several years is a little bit of a barrier to entry. So it's complicated. You have to hire specialists that know how to deal with 3D scanning data. You need to hire maybe a specialist in the office that knows how to register data. Sometimes you have to spend a lot of money on the equipment, and maybe you don't have jobs to keep it busy all the time. So by having something integrated into a survey tool you can use on traditional jobs, your investment is protected. So you can go use it every day as a total station, and some days as a scanner, but most days as both, as we'd like to see. So the way that this is all integrated together, it brings an incredible amount of versatility to this single solution, right? Like I said, you can go out every day as a total station, do your traditional workflows, whether your deliverable is a 2D deliverable for your customer, or whether you want to add context. You think about doing a boundary survey where you're the surveyor, you're going out and capturing very precise measurements, but you notice that there might be an encroachment onto that property. You can quickly frame that out, scan that in high detail, and you have that information to take back and have, for protection, for the discussion around whether that was an encroachment or not, all without losing any time, spending any more effort. You didn't have to call in somebody to come scan it because you have that capability. So as you grow your business and opportunities come along, you can use this single investment to address those opportunities. We'll get into just a little bit of the highlights of the system features. So I mentioned the Lightning 3DM technology. Our engineers in Sweden have done a fantastic job putting this together. What's unique about this is there's true scanning hardware built inside the EDM telescope. So this is not a laser that's measuring once, turning, measuring against, turning, measuring, doing that really fast, and we call it scanning. This is actually a spinning mirror that is fanning out the laser, what we call band scanning, and implemented inside of this highly accurate EDM. So a really unique implementation here. The enhanced vision system, as I mentioned, this is a 1 second total station. As such, you need to be able to point accurately. So we've developed the cameras, the mechanism, so that you can do that to 1 second accuracy. You also have overview cameras so that you can know where the instrument's looking, frame, capture site context, detail, and documentation all through this system. Another thing that's important for a total station is the tracking mechanism, right? Surveyors, when you're out measuring with a prism, you want to know that your instrument's staying locked on that prism. So we've implemented what we're calling advanced auto-lock tracking. That's using camera technology to make sure that you're staying on target, staying locked, even in difficult environments. We're also taking advantage of our long history of technical advances, so things like mag drive that are in the S-Series total stations, and SurePoint that helps make sure that your instrument is pointed where you want it to be pointed, and things like integrated surveying. For those of you who don't know what integrated surveying is, that's taking GPS and being able to go out and do those measurements while your instrument's working, all in the same job without creating separate files. It's all done together. So in this instrument, it's very unique because you're scanning, so you're getting high detail. While that instrument's scanning, you can be walking around collecting very accurate GNSS measurements. Maybe you're walking curb lines, or you're walking the edge of pavement, things like that. While the instrument's scanning, so you're getting sort of double the efficiency in that environment through integrated surveying. I talked about this a little bit. Some of you may be familiar with Trimble Access. That's our field software. If you know Trimble Access, you could get started with this instrument with a few tips and tricks, and you're off and running. Right, the learning curve is going to be very short. The ramp-up time, the training is going to be short. Similarly, we've got Trimble Business Center is the software. As innovative as the instrument is, the tools built into Trimble Business Center are just as innovative. We've implemented automated processes in the Office software to help you create deliverables, things like automatic extraction, segmentation, and things like that. But all this data is available to you when you walk into the office. There's no registration necessary because you're following a survey workflow. All your point clouds are tied to your survey stations. The instrument allows you to do sort of free stations or scan stations and cloud-to-cloud register those in the office as well, so that versatility comes into play. But if you're just doing a survey workflow, registration's eliminated. The data's ready to go to work when you open up the office file. For those of you who are familiar with our scanning applications, Trimble RealWorks, this instrument will work in those workflows as well. So if you have applications that are more pure scanning, where you just want to scan lots of items, maybe the interior of a building, you can use that instrument in that manner, bring those things into Trimble RealWorks, do a full registration, and work on your tools in that. So processes for both, and interaction between those softwares as well. A quick specification highlight for those of you who like to see a data sheet, specifications. So I mentioned this already. It's a 1 second survey total station. This is our best total station that we've built to date, I believe. Prism, accuracy there, 1 millimeter, 1.5 ppm, and from a reflectorless accuracy of 2 millimeters plus 1.5 ppm. That's the best on the market that I know of. Typical total station capability, 5,500 meters to a prism, 800 meters reflectorless, and auto lock ranges. We don't sort of spec a hard range on auto lock because there's determining factors there, but effective auto lock ranges. We're using two types of communications, so much of the work that you're going to do is going to be over Wi-Fi, so you have high bandwidth, high speed, low latency on video between the instrument and the data collector. That point cloud and image capture is all coming over very fast onto the data collector into your job file. And when you need to take a long-range survey shot, you simply switch to long-range radio, and you can go out to those 800-meter type ranges, collect that survey measurement that you need on critical items. This is a real scanner, 26,000 points per second band scanning technology. Very accurate, very low range noise. Take a look at the data sets that are over here on the PCs and check them out. There's some amazing data sets. These instruments are incredible. And cameras, right? This is an imaging system. So we use 3 cameras for the instrument. We have an overview camera, a primary camera, and a telephoto camera. so that you can see the site, guide the instrument, through touch and through the tablet interface, and sort of seamless zoom through those cameras all the way to the telephoto camera, so that you can pick and aim very precisely to 1 second accuracy. Additionally, I mentioned there's a camera in the tracker, but we also have implemented what we're calling a video plummet. So we have a camera plummet for stationing over known points. So this provides you the ability to capture that as documentation right along with your job, with your survey station, for record keeping. You can capture all the station information, the instrument settings right along with that as part of your job file from anywhere. So from the rod, 800 meters out, you can capture that information. If somebody walked by your setup and you think maybe they bumped it and it moved a little bit, you can check that on your tablet remotely. So we've talked a little bit about this already, just quick covering. Lightning 3DM is the smallest spot size on the market, providing full prism and reflectorless capability along with true high-speed 3D scanning. A full dome scan with the instrument at course level takes about 12 minutes. Another 2 or 2.5 to capture full dome panorama set of images to colorize that point cloud. Those scans are automatically registered to your survey workflow, just like I mentioned, and it's completely integrated with the camera system, so it's all working together in concert and accuracy. So all of the things that Trimble has innovated over the past couple of years with Trimble Vision are all able to be taken advantage of with this instrument as well. We talk about the imaging system. The key here is that you need, for a high accuracy total station, you need high accuracy aiming. The vision system in here allows us to do that, to aim to 1 second accuracy. It also provides that rapid instrument control. It's touch screen, wide field of view, so you can locate your objects, frame your objects very, very easily, but total station precision. The camera plummet, as I mentioned, allows you to document, but it also is a more stable setup than a traditional optical plummet, requiring less trimming and adjustment over time. So we think that's going to be a more improved technology to use, and we mentioned the tracker. Again, the key thing around the tracker is simply to make sure that you're maintaining lock, right? You as a customer don't care how we get that done. You just, when you're out walking around with a rod, you want to make sure that it's locked on your prism and it's not chasing cars or other reflective objects. You can see an image here of a very highly reflective environment and no trouble staying locked onto the prism using this technology. And we mentioned the typical, the traditional Trimble technologies that were also built in here in terms of MagDrive, SurePoint, and the power of integrated surveying. It's it may be hard to see on this screen, but this was a job a couple of colleagues went out and did where they scanned. So this was two instruments, two colleagues in this big mall. Each of them spent about 2.5 hours out collecting data, and all of this data was captured with scanning. They captured line work and things with GPS, and they spent about 5 hours in the office doing attribution symbology to create a traditional 2D deliverable. So that's the kind of efficiency. So in less than a day, basically, they went out and did this with two instruments, and that would probably take you, several days or more to go out and do that with traditional methods. From a system standpoint, we mentioned Trimble Access as our field software. We were using our Trimble tablet rugged PC as the controller. So go check it out with a demo, and you'll see the implementation of that on the tablet screen with live video, along with the information you need to do your survey, the ability to switch between maps and video, and have that all on the screen. So the need for the tablet really comes across when you're driving a visual instrument, right, where you need those cameras. Trimble Business Center, as I mentioned, the software, a full range of scanning capability. So there's a new scanning module that we're implementing with Trimble Business Center 3.80 release. This provides a lot of new automated functionality for handling that scan data right integrated with your survey data. So a very streamlined workflow so that you don't compromise, but you don't pay a penalty for implementing scanning and imaging in your workflow. It's one of the challenges with scanning is, you capture the data really fast in the office or in the field, and you go to the office and you spend days and days and days registering, cleaning, working with that data. So we've tried to strip away that penalty as much as we can, for the survey workflow. The key here is to go out. You can either capture everything you want. It's a capable instrument to do that, or capture just what you want so that you minimize the data footprint. You're not messing around with data that you don't really need, and you can sort of pick and choose what you want to use this for. So really the best of both worlds. Who's it for? Surveyors, right? Built by surveyors at Trimble for surveyors. So people that are out doing survey work are going to love this instrument. It works the way you do. We say Trimble transforms the way people work. Well, Trimble is going to transform the way surveyors work, but we're not going to make you change the way you work. So it's pretty incredible. We also see lots of other applications. Scanning service providers have provided us interest in putting this into their fleet of instruments to work alongside their high-speed scanners. So this is not going to replace GPS. It's not going to replace high-speed 3D scanning, but it's really going to complement those things well. And we see this as being a main workhorse instrument for a lot of you. What do you do with it? Survey, right? All these things, I could consolidate all of these things, right? Topographic general survey, roadway and corridor surveys, infrastructure surveys, volumetrics and earthworks. Those are things that surveyors do on a daily basis. You don't necessarily specialize in one of those. You get called to whatever jobs that you do, and you go do those things. This thing's going to sing. It's tailor-made for those applications. But we see so much more from the versatility of this instrument, whether it's as-built, utilities, power lines. We've seen some wonderful data sets. If you look back at this data set, you see the kind of detail you got out of this instrument with one setup to capture that data. Here's an example of a topographic survey. This is a building. People going out doing a typical 2D map. You see the deliverable there on the right. Some comments from some of our beta customers. We've tested this with beta customers all over the world, and they're coming back asking us when they can get their own, can they borrow it again. The really, really, really wonderful efficiency gains that they're seeing out of this, and it's going to change the market. From a roadway corridor survey, you can see some examples here where you're capturing a full point cloud. This happens to be a riverbed. It's a corridor. You can see the sample point cloud. This was from the ground extraction tool in Trimble Business Center. So one push button click and you extract that ground, take away the vegetation on top. You create the surface, create a center line. That might be for a road, a cross-section analysis tools, and many more in Trimble Business Center. So quite incredible. You think about a roadway job from a safety aspect, having an instrument like this, being able to set it up, scan the road surface, capture all that data, but then go walk the critical features, right? You may need the top of curb, you may need the center line or a manhole that you really want a good elevation on. Go do that with a prism, but you've got that roadway surface from the scan data. And you didn't have to put a surveyor in the road, you didn't have to shut down the traffic, and so you've saved on safety, you've saved money on traffic control, things like that. So from a volume standpoint, right, scanning, has gotten a lot of attention from this type of application. But the blending of both, you think about having to do a very accurate volume. You go walk the base of the stockpile to get you a good, accurate foundation. Do that with your prism measurements, and then scan the pile, and then do your calculations in the Trimble Business Center. Create your volume report, all with this instrument. If you don't need to walk the stockpile, again, it's another safety piece, right? You don't want people walking out there in these dangerous environments, being put in harm's way if they don't need to be. And then infrastructure as built. You can see some examples here of a tunnel project that was done. Wonderful data, very few setups to capture that information very quickly and bring that back into the office software. And many, many more, right? Our customers that have tested this are seeing all kinds of applications that can be used with this instrument. So really excited to present it to you. we've got a few more minutes, I guess, if we want to take some questions. Does anybody have any questions we can talk about? All right, nobody's going to do it. There's a big crowd here. I get it. Feel free to come up to all of us, get a demo, come up to the podium, ask me questions afterwards, and we'd love to show you the instrument, show you the solution. We're really proud of it, and hope you'll get excited about it too. So thank you all.